All right, hello. This video is on topic 1.6, describing the distribution of a quantitative variable. All right, the objective is to describe the characteristics of quantitative data distributions. All right, so there are 4 different characteristics that we have to discuss or address with quantitative data, and you can remember them with the acronym CUS. So the C stands for center. We want to identify the center of the distribution. The U is for unusual features. The first S is for shape, and then the second S is for spread. So I'll talk about each of these characteristics in this video. All right, so the center of a distribution should represent a typical value that you would imagine has a lot of data around it or nearby. So the easiest thing to do is just kind of look for the peaks of the distribution. So this histogram to the right has data on female shoulder girth, and I can see that there's a peak. And if I kind of estimate where this peak is on the number line, it's probably like at 99 or 100. Okay, so that would be a good value to use as the center, right? Typical females have shoulder girths, around 99 or 100 centimeters. Right. Let's talk about unusual features. Now, there's a couple different things that might be unusual, the first of which is an outlier. So this is a data point that is extremely small or large compared to the rest of the data. So if we look at the histogram of female shoulder girths again, we see over there at the right, there's some data around 128, okay, which seems to be pretty large compared to the rest of the distribution. Okay. Normally you can identify outliers because you will see some gaps. Notice that there's a small gap between this huge pile of data and then these 2 bars or bins over here. Okay. So gaps are kind of telltale signs of maybe potential outliers or also clusters. Okay, so clusters are concentrations of data usually separated by gaps. So here's an example of clusters, right? We're looking at test scores for a class of students, and we see this gap here in the middle. There weren't any scores in the 50s. And then we see a cluster of scores on the low side and a cluster of scores on the high side. So generally when you see clusters, that's an indication of maybe some subgroups in your data. Right? We have a subgroup of students who didn't study versus the subgroup who did study. Okay. All right, let's move on to shape. So here are a couple shapes you might see in some distributions. So bimodal or multimodal are going to be distributions that have 2 or more peaks. Okay, so bi would be 2 peaks, tri would be 3 peaks. Okay. Unimodal would be data that has only 1 peak. And then uniform would be data that doesn't really have a peak. The data is kind of evenly spread or evenly distributed throughout. So think about like when you're mowing the lawn, you want to have a nice uniform cut in your grass, right? You don't want to have patches where the grass is really high or really low. You want everything to be pretty consistent, and that's what a uniform graph looks like. Has kind of like a, if we were to outline this, it would just kind of look like a rectangle almost. Right. There's some more shapes to be aware of. Skewed left would be a distribution that tails off to the left side. So there's a lot more spread in the lower values. Roughly symmetric is data where the distribution, it looks like mirror images, the left side versus the right side. And skewed right would be a distribution that tails off to the right side. So now there's kind of more spread in the higher values versus the lower values. So here, these terms all refer to kind of the tail end of the distribution. Okay, if there's a long left tail, skewed left. If there's a long right tail, skewed right. If the 2 tails kind of look like mirror images of each other, then it's symmetric. Right. The last characteristic is spread. And so we're just going to talk in very general terms right now. So values might look very similar to one another. Right, so here are some exam scores where it's like everybody got a C, right? 70 to 80 would be a C. So there's low variability, right? The scores here show a lot of consistency. Values could then differ more and more. So now we're starting to see that those scores are getting more spread out. Now we have scores in the 60s going up to the 90s. And then if you have values that differ substantially, right? Very, very low scores and very, very high scores, now you see a high amount of variability. Okay? So low variability is when things are really kind of clumped close together, and then high variability is when our data is spread out far apart from one another. Okay. We're going to describe spread in more technical terms in a future video, but now just think of it as either the data is close together or it's far apart. All right, so here's a tip for the AP exam. If a question asks you to describe the distribution of some quantitative data, you have to address all 4 of the characteristics listed on that earlier slide. So center, unusual features, shape, and spread. Okay, and not only must you address those 4 characteristics, but you have to do it in the context of the problem, right? So within the setting of the problem. If the problem is about exam scores, you have to mention that in your response. If the data is about female shoulder girth, you must mention that in your response. And if there's units, it's a good idea to include units as well. All right, so here is an example of how to address that on an AP question. All right, so we have a dot plot of fuel efficiencies for some Toyota 4Runners, and we want to describe this distribution. So first we could say that the fuel economies for these 2018 4Runners are roughly symmetric, so I'm addressing shape there, and centered around a typical value of 22.4 miles per gallon. So I've addressed shape and I've addressed center. Okay, I've also already included context because I'm talking about the type of car, the variable, and the units. All right, there appears to be a low outlier at 21.5 mpg and a high outlier at 23.3 mpg. Okay, so now I've addressed the 3rd characteristic, unusual features. Okay, and then now I just have to mention the 4th one, which is spread. Okay. So the majority of 4Runners have fuel economies between 21.9 to 22.9 miles per gallon. So they're pretty much within 1 mpg of each other, right? And that's, I would say, pretty consistent for cars, right? If a lot of cars can be within 1 mpg of each other, I would say that's showing pretty good, I guess, quality control at the car factory where they're manufacturing the cars if they can get within 1 mpg, right? You're not seeing, cars with extremely low or extremely high mpgs, pretty consistent. Okay, so that's how you would attack this kind of question on the AP exam. You address the 4 characteristics, plus you got to include some context as well.